Hello everyone, Anthony here with the second episode of how to create a blockchain from scratch, where we're basically creating a complete production ready, fast, modular blockchain, general purpose blockchain from a blank page in Go. And in the first episode we started to scaffold a server object with a local transport. And I think now it's time to basically start mocking out or basically start building out blocks and transactions. So without further ado, let's get started. The first thing I'm gonna do is, so we have network. This main file should basically house into CMD, into a command line later on. But for now it's good, no worries about it. So I'm gonna make a new folder. I'm gonna call it core. Yeah, core is good. And we're gonna make a new file in that. We're gonna call it block.go. And maybe we should make a new file and call it transaction.go. And wait, let's just first start doing package core type transaction. We're gonna, this will not be definite. We will change things up as far as we go, but first, for now, let's just make it work. It's my motto: make it work, make it better, make it fast. So transaction, just to stop making the compiler complain. Block, we do the same thing for block. Let's just copy this, boom, 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 and we name this to block, like this. For block, by the way, we also need a header, which is a block header, transaction. Cool. Another thing we certainly need is kind of a types package. Because the reason for this is basically a block will have a hash, and a hash is going to be our own type. But let's wait for that. Let's do it later on. Let's delete this, and this. Cool. Block. So let's just start filling out the block with some things we need. It will not be all of the things, but where I can come up with is basically we need a version. How are we gonna name this thing? What should be the type of this? Let me quickly think about this. Wait. Let's just do header, right? So basically, for the people that don't know, a block consists out of a header, and the reason for this is because if we want to hash the block, which is very important, we cannot hash everything. And we also want to save space. So for example, if we want to keep track of blocks, but we don't want to keep the transactions just to save space, then we can just include headers, because headers will have no transactions in it. So it can be used to only hash the header, and it can also be used to save space and only include headers. But that will be more clear later on. So for version, I think I'm going to use a uint32. We need a pref hash or block maybe, which will be types.hash. We don't have that. That's no problem. Let's make it. Let's go here. Types, new file, hash.go, package types, type hash. Couple ways we can do this. Type hash. This is gonna be a uint8. Actually, it's gonna be a 32-byte uint8. That's gonna be a hash. So it's going to be a types.hash. Why is it not working? You see, it's like Visual Studio is not able to import my own things. It's insane. Let's do it again. Pref block. Come on. Pref block types.hash. Okay. And we do it like this. Boom. Works fine. Types with hash. We need a timestamp. We also need, but first timestamp is going to be this time Unix Nano. I think it's a UN64. UN64, I'm not sure. We need a height, which is a UN32, and we need, do we need a nonce? Yeah, we need a nonce. UN64. I think that's fine. And then in the block we will say it's a header, and we will have transactions, and it will be a slice of transaction. Yeah, there will be more fields, but for now it's good. Okay, so first the hash. So like I said, there's a couple ways we can do this. First of all, we need to make something like hash from bytes, which is b bytes hash. The reason why we need this function is because we're gonna hash the block SHA-265 hash, 56 hash, I mean, and that's gonna return a byte slice. But we don't want, actually it's not returning a byte slice. Doesn't matter. We need this function anyway. So we're gonna say if length b is not 32, then I'm gonna say the provided bytes wait, how are we gonna make this error? Given bytes with length person D should be 32. Len B. FMT. We're gonna panic, right? I mean, normally panic is not a good thing, but I mean, hash from bytes, we cannot continue. If this is not 32, our system cannot continue. So if it's not if it cannot continue, just panic and call it a day, you know. Cool. So now we're gonna make a value which is a 32 bytes. No, it's a 32 UN8. Excuse me. And then we're gonna say equals 0 smaller than 32 y plus plus. This new keyboard is killing me. I like it, but it's just the keys are a little bit too high, and then I mistype myself so many times. We're going to say value y b is byte y, exactly. And then we say return hash value. Okay, and what do we need more from this? Nothing. Okay, cool. So this is basically a placeholder for the future. Another thing we need to do is if we want to send this block, let's do this first actually. If we want to send this block over the network, we need to make it a byte slice, right? So like I said, there is so many ways we can do this. We can use so much encoding algorithms and protocols and whatever we want, but I think we're going to make it very simple. And it's going to be func header. Should we use a pointer to this or not? That's a question actually. I'm thinking. Yeah, we need a pointer. We need one. We're gonna say decode binary. Decode binary. Decode. First encode basically, but that's fine because we need decode also. And encode binary. So what we're gonna do is basically take all these fields and we're gonna encode them into a byte slice. And then there should be a way to, if we get a block in a byte slice, we should decode it to a header. Back again. So encoding is writing, so we need an io.writer. And I'm not quite sure about these errors, to be honest. And I will show you why. IO reader. And we're gonna say binary writes the writer. Let's use little endian. So what's little endian? You also have big endian, and it's just the way how the byte orders work. And to be honest, it doesn't really matter. It doesn't really matter. It's basically you're the boss. You know what I mean? You can decide. Little endian, big endian. You can just do whatever you want. You're the creator. You're basically the god. Wait, because I'm confused now. So basically, binary upon little endian, and then we say header upon version. And then we need to do the same with all the other fields. The pref block, the timestamp, the height, and the nonce. The reason why we do encode binary like this is it's very generic, and what I mean by that is instead of returning a byte slice here, we just passing a writer, so that could be anything. And again, it's super extendable by doing this, using interfaces. So now the error. So the problem is this will throw an error, and then we need to say if add equals to this add not null, and then we return the add. This is nasty, but it is what it is. It is what it is. Let's copy this. It's 1, 2, 3, 4, 5 times actually. 1, 2. Let's delete this. Oh man, what? I'm messing it up. Like this. Version. Block. Timestamp. Whoops. Height. Nonce. So what we also could do, but that's maybe for later. This one can be just this, to be honest. Exactly like this. What we also could do is create some space in here. So we could create a space thing and put some bytes in it, just so we have space for the future to append some other values if we want, just to make it more compatible. But for now, it doesn't matter because we will shift it. It's not that we're in production yet, so we can shift it whenever we want, and it is what it is. So we could also. That's why the version is very important, because you could basically, to make this pinpoint perfect, you need to read the version, and based on the version, decoding happens for the next fields. But that's all later things. First, we just need to make it work. So encode binary. Decode binary is basically the same, exactly the same. I know it's a little bit boring, but like I said, we're gonna do everything, and if you want to do everything, you need to write everything. So yeah, exactly. So decode binary is a reader, so we need to change this to reads r. What the hell is happening, Pim? Hello? Like this. read, and I know I could do this much faster with some keybinds and whatever, but it's okay. Read, I'm still 100 times faster than your mouse. Yeah, exactly. So we can decode, we can encode, and the same for block. So let's first write a test. That's always very important. Block. Let's create a new file. Block test. Go. Boom. Package core like this. Func test header. Decode. Encode. Decode. T. Help. Testing. T. This. Okay, let's open up the block next to us. Test header, encode, decode. So now we're gonna make a header. So we say is a header version is 1. Okay, cool. So now what we need to do is go to hash and make something like, because I wanna basically put in a random hash in it, so I need to make the function myself. Random hash. How I'm gonna do this? A lot of things, to be honest. How can I do this? Maybe something with rand read or something. It should be an utility function, but it is what it is. So random bytes in size, no, which size int. Return this. So I can say token is make a byte size rand read, yeah, token maybe, yeah, return token. What is token actually? Okay, cool, yeah. And then we can say return hash from bytes. See that this function will come in handy, I told you. Hash from bytes, and then we say random bytes, and we need 32 in this case, and we're all Gucci. So now, come back to block. We can say that the pref block is going to be, the pref block is the hash of the previous block, which is a default blockchain mechanics. So we're going to say the pref block is, wait, is it types? Random hash. And then we need a timestamp is time now Unix nano. It's an N64, okay. Okay, boy, I give you what you want. And we need a height. The height of the block is, what a lot of people know is basically the index is, yeah, the height of the block. If you have 3 blocks, you will have 1 genesis, and then height 2 or 3, whatever you wanna. If you wanna include 0, depends. Like I said, you're the painter. You're the Bob Ross. You're the Bob Ross of the digital space. Height, let's give it 10, I don't know. And then we need a nonce, which is basically a UN64, which can be anything we want. And then we say buff is bytes buffer, come on, like this. And then we say encode binary, and we give it a buff. So that's the reason why it's so interesting. So we could actually, so right now we put in the buffer, right? Because buffer is a writer, but we could basically encode binary and put in a connection into it. So we could basically stream, by doing that we can stream the bytes of the block if we want, and I think we will do later on in TCP transport rather, sorry. So encode binary, we need to assert this to no. And again, do we have a test I can just steal something from? Block test is the same we have, a local transport test. I don't know why it's not working. So this should be empty, and then we're gonna make h decodes is a header, and then we say h assert no t h decode point decode binary the buffer, and then we need to compare those two, assert point equal. And guys, if you have any questions, please let them know in the comments. Maybe I'm gonna live stream this, but the problem is there will not be a lot of people watching it, so it doesn't make any sense. So I'm just live recording it. If you want to ask questions, you can always mail, whatever. You can reach me whenever you want. Wait. So we're gonna equal. So let's recap. We have a header with some fields. We encode it binary, so we make it a binary representation into the buffer. Then we make a new header. We decode it from the buffer, so basically means that the h should be the same as h decodes. Make test. Yes, we're perfect. We are Gucci. And enable to show you guys how it looks is basically, let's just buy it, so it doesn't matter. So the test is working, so we're happy. Yeah, we're happy. The next thing we need to do is do the same for block, and basically help block is very simple, so let's basically copy this and say it's very, I know it's boring and there's going to be a lot of cool things going on coming up in future episodes, but it needs to happen. Like I think next episode we're going to do the key pairs, generating addresses and everything. It's going to be super cool and educational, but it needs to be done, because if we cannot decode this, encode this into bytes, we cannot hash it. If we cannot hash it, then we are basically back to front end. Decode binary block. So I need to focus a little bit. So let's copy this. Let's make it encode binary. And we can make this an interface later on if we want. Encode binary. I open the writer. Visual Studio, please. We're gonna say if headers encode binary W this, and then we need to decode all our transactions. So in order to do that, we need to open up transaction, please, yes, and we need to, just for a placeholder, I'm trying to be so fucking fast that I'm making so many mistakes, but I just want to get this done because I know it's boring as hell. And okay, cool. So we have these two things. So now we can say for each tx that's inside of our block transactions, we can say tx encode binary with w. I need to do it like this. So the error handling in Go is, I don't know, It's the only thing I actually don't like, to be honest. But it's basically a blessing and how do you say that? It's the devil and an angel. It's the devil and the angel together. Return the errors. Okay, cool. And then right here we return nothing. And the same thing for decode. So we're gonna copy everything over, paste it in here. Decode binary, reader. Decode binary, reader. Go back to test block. For the people that don't know why I'm moving so fast between everything and closing and doing stuff, it's the Vim plugin for Visual Studio Code, and I have some custom key bindings enabled to go to terminal and close things and make new things, new panels and everything. I will link my config in description if you guys want to know. I rather recommend to basically reprogram yourself and diss your mouse and use Vim. You're gonna be 3 months slower than you were before, but after that you're gonna be 100 times faster than you were before. So you need to sacrifice time and able to buy time in the future. That's how life works, guys. Let's focus up because I'm basically sleeping. Okay, so we test header. This is working. So now we're gonna, as last thing we need to do is basically test block, encode, and decode. Testing. We're gonna make a block. We're gonna make a header. And this. Can I do this? I can't. What's going on? What's going on? So block, header, version, all this stuff. Close this thing. It's not working. Maybe it's like this. What the hell is going on? Ah yeah, maybe it's because, yes, oh man, oh sorry. Like this, and then transactions. These are gonna be null, because we don't want to hassle with those quite yet. And then exactly the same, so we're gonna copy some stuff from here, paste it like this, then we say assert t deep and decode binary, it's encode rather, with the buffer, block decode, it's gonna be a new block. I'm gonna test something, maybe we can use it without pointers, to be honest, not quite sure, maybe we can, or maybe we can't. We're going to decode it from the buffer again, and then we need to compare those two with the block and the block decodes. Make test. It's working. Let me quickly try something. Like this, and then do B decode just to see. So this is the decoded block, And you can see that we have the version, we have the header, we have the version, timestamp, height, nonce, and then 0 transactions because we have none. So it's working perfectly fine, which is good. So we are done with this bullshit. That's nice, but it has to be done. How many minutes do we have right now? We are in 30 minutes. So we can stop right here, and because we have a good base right now. Because the next thing we need to do is go into transactions, and we need to basically let's fill it in right now. So for transactions, how it will work is we will have data, which will be a byte. And this will be any kind of arbitrary data. For example, like I mentioned, this blockchain is not crypto specific, it's generic. So people can use it for, I don't know, for something like food chains or for crypto stuff. It could be used for office files. It could be used for anything. So a transaction is generic. For example, if we are gonna build our own chain with these modules, and that will be crypto specific. And if we wanna implement the EVM, for example, which we will do, but we will not write it ourselves because that's just crazy stuff. But we're gonna make adapters so we can plug in the Ethereum machine into our own blockchain and build it from there with some modifications maybe. And in that case, data will be a script, right? It will be bytecode, it will be Solidity code, and so on. And for other people, it could be something different. Maybe it's pornographic material. I don't know. You're gonna tell me? I don't know. Whatever. Like I said, you're the boss. You can do whatever, but whatever you want with it. So data, and then we will also have a wait. I know what we need to do first. My apologizes. So basically, in order to hash this block, we need to do something. I'm just remember it. So a block need to be hashed, and that's the last thing we're gonna do. So we're gonna this episode. So basically, the block. I'm gonna give it a function hash, which will return a hash like this. It's a type-spent hash. I'm getting really tired and sloppy in my typing, I'm gonna lie. We're gonna cache it, because each time somebody's gonna call hash, and we need to basically do this, we need to do the cryptographical 256 hash from it, then it will be costly. So what we're gonna do is make a thing like this, type-spent hash, and we say cached version of the block hash. Basically header hash actually. This. Let me think. Okay, so what we need to do is we need to make a buffer first, like we did in our tests, and then we need to encode the header like this into the buffer, and then we can use this buffer and able to use it as a hash. Beep and hash. This type-spent hash. Is this gonna work actually? I think so, maybe. Buff. Buff. Bytes, maybe? Yes, okay, cool. Are we gonna wait? And then we return beep and hash, but the thing is, we need to make a helper function hash. So what I want to do right here is basically compare it, right? So we want to cache it. So basically each time somebody calls hash and the hash is empty, so basically this thing is empty, then we will hash it, set the value and return it. But if it's not empty, we can just return it, so we don't need to calculate this, and we save performance. I'm able to do that. I need to compare it, and then I need to make a function, func hash. Come on, please. Visual Studio S0 bool. How is this working? Okay, just loop, I guess. Smaller than 32. I plus if false, turn true. Wait, let me just recap. So basically, we have 32 times this UN8, we loop through it, and then we check if the value is not 0. Yeah, it's false, otherwise it's true. So yeah, this is working perfectly fine. So then we can say if b.hash is 0, if it's 0, then we will do this, and otherwise we will return yes. So that's perfectly fine. So we could make a test basically if we really want for this 0 thing. To be honest, but I think it's fine. Should work perfectly fine. Okay, cool. So we can hash the block, which we will need. And maybe we can do some, the last thing we can do for this thing is basically func hash string. So Golang has its own string interface, and what it does is basically whenever you put a hash, whenever you put an object that implements string into something that's printing, it will instead of printing its struct or whatever, it will print this string representation, the one you implemented it. So we can do like hex.equal to string, and we cannot do this. So we need to make another function, which is hash to slice byte is b make byte 13. Yeah, because we cannot put a 32, an exactly array of 32 UN8s into this thing, so we need to make it a slice. And then we can say a to slice, and then we have a string representation, and if we then go to block test, which is the last thing we will do, is something very simple, print test hash test block hash testing like this. Should we copy it? Why not? Let's just keep copying stuff like this. Up, and then transactions, that will be null. You could do nil or even just do something like transaction and then this, which is basically kind of the same. And then we're gonna do assert punt. Wait, we're gonna do like hash. It's basically d punt hash. And then we're gonna say assert punt true t or false maybe. H punt is 0. And maybe for the sake of demonstration purposes, println like this, and then test it. As you can see, this is our hash of our block, and it's all working perfectly fine. So this is it for episode 2. We basically already have a transport. We created the scaffolding of our blocks and our transactions. We can decode and encoded binary, which we will need for transportation, which we will need for hashing, which we did. The next episode is going to be an interesting one. It's going to be crypto related, because enable to verify and put transactions into blocks and whatever you want to call it, we need to sign it. And enable to sign it, we need public keys, private keys, addresses. We need to derive it. It's going to be super nice. It's going to be interesting, educational. So if you like this video, please like the video. It's so weird. Like the video, subscribe to the channel, leave something in the comments, ask questions, I don't know, maybe roast me. It's all good, it's all good. And see you guys into the next episode. Peace.